a table for this greatest integer. And since we want to see what an integer does, let's put some decimals in here, because otherwise you might not see how it works out. So what I'm going to do here is I'm going to go negative 1.5, negative 1, negative 0.5, 0, 0.5, and 1. Then let's just do the x plus 1 for now, because it's kind of confusing with all these steps. And then what we'll do is we'll do the greatest integer of x plus 1. So negative 1.5 plus 1, well, that's negative 0.5. Negative 1 plus 1 is 0. 0.5 plus 1 is 1.5. 0 plus 1 is 1. 0.5 plus 1 is 1.5. And 1 plus 1 is 2. Now, I'm going to take each of these numbers and I'm going to round it down. I'm going to pick the biggest number that's an integer that's less than or equal to that number. So the biggest number, the biggest integer for negative 0.5, well, that's negative 1, isn't it? 0, well, that's 0. Don't have to do anything with if it's a whole number. So 1.5 is 1. 1 is 1. Oh, I got 1.5 on there twice, don't I? That's supposed to be 0.5. Sorry about that. So 0.5 is also 0. 1.5 is 1, and 2 is 2. So if I'm at negative 0.5, I'm going to be at negative 1. So I'm at negative 0.5, I'm down here at negative 1. Then I'm going to graph 0, 0. This is where you can start seeing it. So 0, 0. Anything that is smaller than 1, well, that's going to stay at 0, isn't it? So I'm going to go all the way here to 1. I'm not going to include 1. So let me make this thinner again. It's pretty thin the way it is. So I'm going to go all the way to 1, and then I'll draw a segment connecting. So anything between 0 and 1 is going to be at 1. And then once we get to 1, we jump up here. 1 plus 1 is 2. And this is where you get your step function. And I could have drawn it to the left also. I started at negative 0.5 just so you could see that. Okay. This would be filled in. Then I drop down here. And so on. And there is your step function. I think when I do this in class, I'll put some more decimals on here, because I don't think I have enough there to convince you that we got this. So maybe I should have done like 1.25. 1.25 is also 1. 1.75 is also 1. And there we have it. And like we said, we could go on forever on this one. So my domain, I'm going to include all my numbers, right? So my domain is any number in the number line, so we call that all real numbers. But my range, my y values, they can be numbers, but notice it jumps. These are just plain old integers. No fractions or decimals. So like negative 3, I'll go dot, dot, dot. Negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, dot, dot. And that's what we do for that one. Okay, let's take a look at this one. Here we have a design question. A state requires a ratio of 1 lifeguard to 60 swimmers in a swimming pool. This means that 1 lifeguard can watch up to and including 60 swimmers. I want to make a table and draw a graph that shows the number of lifeguards that must be on duty, f of x, based on the number of swimmers in the pool x. So let's make a table here. So X is going to be the swimmers. Y is my lifeguards. So let's go like 0, 20, 40, 60, 80. I want to do a few more of these. 100, 120. I think we get the idea there. Okay. If I have no swimmers, hopefully I shouldn't need a lifeguard, should I? 0, 0. 20 swimmers, I'll need one lifeguard. 40 swimmers, I'll need one lifeguard. 60 swimmers, I'll need one lifeguard. Then it jumps to, when I get to 80, then I'm up to 2 lifeguards. Actually, when I get to 61, I should be at 2 lifeguards, shouldn't I? Okay, 100 is still at 2 lifeguards, and then when 120, I'm still at 2 lifeguards. So now let's graph this out. So when I'm at 0, well, let's label this first. So I'm going to put swimmers here as my independent variable. And then let's count by 20s. So I got 0, 20, 40, 60, 80, 100, 120, 140, and so on. Now, since I don't have to have that many lifeguards, what I'm going to do is I'm going to count by quarters. So, but I'm not going to put in 1 quarter. So 0.25, 0.5, every fourth one is 1. So 1, 2, 3, there's 1. 1, 2, 3, there's 2. 1, 2, 3, there's 3. Just so I can get them spread out. So I know 0 lifeguards, I'd have, or 0 swimmers that I have 0 lifeguards. Then anything over 0, I'm going to put an open circle on 0. On 1, I'm sorry. I'm going to put an open circle on 1. I'm going to make this a little bit bigger. Open circle on 1 because I'm counting by 20, so I can't really just put 1 in there. But all the way up to 60, and including 60, that's going to require 1 lifeguard. Then anything over 60, I'm going to be at 2 lifeguards. And that will be all the way up until 120. Nope. Didn't have my pen mark there. And then, so do you see, it's a step function here again. Because if I have like 25, I got 1 lifeguard. 59, 1 lifeguard. But 61, 2 lifeguards. 121, 3 lifeguards. So if I look at the next one, I'd have an open circle on 120. Then I would go out until I'm at 180. And there is your step function. And the lifeguards was on my side here for Y. I didn't label that because I didn't have a lot of room, but probably should have labeled that.